Hi, I'm Pagata12, and today we play with matrix multiplication by a column vector again, because my first attempt, my previous tutorial, was full of errors, and I had to take it down. I hope this time I'll have a more coherent and error-free explanation. I would also like to thank Joseph Pels for pointing out my mistake. So yeah, let's jump in Paint, and I would like to take the same numbers. So we have this matrix with 5, 7, 8, 2, 3, 1, and 4, 9, 2. So okay. And we multiply this with a column vector 7, 2, 1. Okay, and let's see this as a result is a column vector also, and the first item is 7 multiply with 5 plus 2 multiply with 7 plus 1 multiply with 8. Now let's have the next row. It's 7 multiply with 2 plus 2 multiply with 3 plus 1, so it's plus, sorry, just a second, okay, plus 1 multiply with 1. And the last one, it's 7 multiply with 4 plus 2 multiply with 9 plus 1 multiply with 2. So we notice we have those pairs, okay, 3 and also 3 rows. And I was thinking, yeah, using RGB structure of a pixel, we have room to compute this math. And yeah, let's see. We have these pairs. I will only draw with colors the first row and this column. Okay. And the math is done between this column and those rows, okay? And yeah, what if I'll have this matrix like this? So I'll have first column being the red value, the second one the green value, and the last column would be the blue value, okay? And I would also like to flip it. So if I flip it with bottom left and then flip X, okay, this can stay like we have 5, 2, and 4. Okay, so now this red column I want to align against this red value of my vector. Okay, so the next row would be 7, 3, 9, and then I'll have 8, 1, and 2. So now let's see here, 7, it's getting multiplied. What this one is getting multiplied with 5, 2, and 4. 5, 2, and 4. Okay, so if we now multiply those red, okay, because those are red, right? Green and blue. So my first pixel, okay, is this one. Oh, sorry. So my first pixel, my second pixel, and so on. now when I multiply with this vector, with 7, I multiply the red value, okay? With 2, I multiply the green value, and with 1, I multiply the blue, okay? And after this operation of multiplying, okay, then I can add the channels, okay? So red plus green plus blue, okay? So then I'll add together those, and yeah, you notice we get here, so 7 5 plus 2 7 plus 1 8, and all the rows, okay? And this is how we arrange the texture to do the math, okay? So let's go back. We'll try to recreate this, and yeah, let me copy. We'll use a rotation matrix, simple rotation matrix on x-axis. So yeah, let me have this here. I will delete this old network. Okay, oh, I'll have it already. Okay, so let's have our vector is noise, 1 pixel. So, okay. So we have this vector, and if we want to rotate this, let's say with 39 degrees on x-axis, let's see what we should have. So for this I use a point transform, okay, and I transform with 39 degrees, okay. So let's see what we have. View as color, okay. So yeah, we need to get to this color, okay. Now let's have a constant for our angle, okay. So I can drag the value right from here. So okay, and this is 32 mono. Okay, now I wanna shape the matrix, so I'll go into folder, okay, like this. So null. Okay, I'll have a folder. I name this matrix. Okay, and let's go inside. And for the input, we have this 39 angle. So let's use a function. Okay, and I'll have a cosine here. Degrees is good, as this is a cosine. And let's have a sine. Okay, and you see we also need minus sign. So with a math, I can multiply with -1. So -1. Okay, and what else? We need 0 and 1. So let's have a constant. 32 mono, 1 pixel, and this is 1. It's good, and this is 0. Okay, so 1 and 0. Now with a layout, we can build the rows. Okay, so this would be left to right. The resolution is 3 by 1. Okay, and let's copy this. For the middle row, in the middle row it's 0, so I'll have a 0. Okay, the second one it's cosine. Let's go with cosine for the middle, and the last one it's minus sign, so minus sign for the last one. And now I copy this once again, and I'll have 0, sine is the next one, and cosine. Okay, so let me check again. So it's 0 sine. Okay, but this one takes the sine. Okay, now it's good. And let's have a final layout. This time it's 3 by 3. So we go custom resolution 3 by 3, and yes, like this, and it's top to bottom. Okay. And let's have an out here. Okay. Now I would like to arrange this matrix in a RGB pixels. So I will take the red of the first column, the green for the middle column, and the last column blue. Let's do that. So we have a null here. Okay, collapse selected. This is matrix to RGB. Okay, and we go inside, and here let's have a group, and we group 1/3. Okay, here a next one would be 1/3 to 2/3, and the last one would be 2/3 to 1. Okay, let's have this nearest pixel. Okay, now I'll have a reorder, and I'll take input 2 for the green and input 3 for the blue, and this texture is RGBA. Okay. So now this, let's multiply those two. So multiply. Okay. And then we use a mat with add. Okay. And this mat, I will mask the alpha, and I'll go with add. So yeah, like this. This should be mono. So we mask the alpha here in combined channels input. Okay. And yeah, we have a vector column, which is our result, but we need to take this into a pixel format. So I can use the same matrix to RGB, but because here we take the columns, okay, for the red, green, and blue. Here we have only one column. So what if we flip this? Okay, remember here we flip it, right? So you either use this flip here with bottom left and like this, okay, or you can use this flip here, right? And yeah, now it's working. And let's compare those two, because this is our result. So let's see the pixel values. Okay, so we have pretty much the same value here. And let me just check this, as this is RGBA and this is RGB. Now it's 32. Now we're good. Now we have the same values, you see. So this is a very precise method, and the math is done very fast. Now once again, I would like to thanks to Joseph for pointing out this to me, because of such a matrix, which is rotation matrix. We have a bunch of zeros. Okay, I messed up the flipping actually, and then the addition multiplication was done between wrong pairs. Okay, but in my output was not that visible, only just an inverted result, which I solve it by changing the minus here. Now this is much more correct. You don't need to adjust for the invert. So this is my method for making multiplication between matrices, and I really hope you like this. Sorry once again for my clumsiness in a previous tutorial, and yeah, thank you massive for your support, and I'll see you in the next one. Bye.